Hello friends, welcome back to our channel. So in today's session we'll discuss about how to implement single linked list in Python. So this is a linear data structure. So here we'll be having a nodes and which is linking with each other. So this is the structure of a single linked list. So every node, so this is a node and every node will be having two fields. One is the data and another one is the link of the next node. That means the address of the next node. So again it will pointing towards the next node. Again we are having some data and the link of next node. So this is the structure of a single linked list. That means every node will be having a single link, okay, which is the address of next node. And here example, we'll take some nodes. So let it be some 10 and the address of this one is some 1100 and it is pointing towards the second node which is of data 20, and this address, this address, let it be some 1200 and this address will be stored here. So current node will be having the data and the address of the next node. Similarly, this node will be pointing towards one more node with a 30 and this node address will be some 1300 and that will be placed here itself. And again we'll take some fourth node with a 40. This is a 1400 is the address and that will be stored here, and this is the last node. So if it is the last node, the address will be null, so there will be no address pointing. Okay, so this is the normal structure for a node. So here this is a single linked list, so for every node will be having a single link and here the link is the address of next node. Now so this will be the head value, so we should not change the head value. So head is nothing but pointing towards the first element of the single linked list. And here the linked list, we'll see first how to create a linked list, and the next one how to display the nodes, of a linked list, In the further sessions we'll go with the insertion and deletions, right? So first we'll create the linked list. For creating this linked list, if you are aware about C language, we have that dynamic memory allocation and we are having some pointers concept. So by applying both things, so every node can be having the two pointers, that is one is data and another one is the pointer variable. But here in Python, so this implementation is in Python, so right, so in Python, so we are not having the concept of pointers. So for that purpose, so we have to go with the object oriented programming. That means we have to create a class. Okay, in order to create a node, we have to create a class with the two variables. Okay, with the two variables, one is data and another one is next. So next is nothing but the address of the next node, right? So here we'll create a class node and we will create two variables for data and next. So that is the first step. That means we have to create a new node. So the syntax for that one is class node colon and use the constructor to initialize these things. Okay, so I will initialize the constructor. So def, so in Python the constructor is _init _self and also consider the data. So because if you create a node, so we have to give the data, right? So colon, so self dot data will be the data, and similarly the second parameter self dot next will be none, because if you are creating a node, if it is a first node, okay, if it is a first node, so this is a first node 10. So what about this address? So this is nothing but data, okay, this is nothing but a data, and this is the next. So for the first node, what about the next? So here we are, the linked list is having only one node, that means there will be no data in the next, that means we are not linking with any other node. So that's why here we'll be having none. Initially the first node address, I mean the next value of first node will be none, right? And so now after creating the nodes, we have to link with the another linked list, right? We need to link with one node to another node. For this linking process, we'll create a one more class called a single linked list. So we'll create a one more class called, so class, okay, single linked list, single linked list. So here I will give some head because the head is the pointing towards the first element of a linked list. So I will go with this again the same constructor. So def init self colon. So for every definition, every user defined function, including the constructor, the first parameter will be the self. Okay. So self dot head is equal to none. So initially there are no elements. Initially there are no elements, so automatically head points to none. After creating one node, the head will be pointing towards this node, right? So the first step, we have created the node, we have created the linked list. Now we'll insert each and every node and we'll link the one node with the another node, right? So for that purpose, so that means just we are creating, okay, we are creating. For this we will create an object, because through the object we have to add the nodes. So I will give some L is equal to SLL. So one linked list is created and it is empty. Linked list is created and it is empty. Now a node is created, N1 is equal to node of, give the 10. So node is created now, okay, node is created. So there is a node 10, right? Automatically if you create this one, 10 will be moved to the data. So self dot data will be 10 and self dot next will be none. So by default here it will be none, right? Now we need to assign head to this one. We need to assign head to this one. So L1 dot L dot, sorry, self dot head is equal to N1. The self dot head will be N1. Now what about the next one? Okay, what about the next one? Create one more node. So here it will be pointing head. Now N2 is equal to node of 20. So one more node is created here with the 20, and by default it is a none because self dot next is none. Now we have to point this address of this node to previous one. So we can write N1 dot next. So because, so this is the data and this is the next, this is a N1, right? So N1 dot next, that means this part is equal to, what is this one? N2, right? So we can write here itself, okay, N2. So automatically the link will be print here, and here none will be replaced with the address of this one. So let it be some 1200. So 1200 will be here, and immediately create a one more node. N3 is equal to node of 30. So again a node is created, because whenever you are creating the object, so N3 is an object for node class. So we are having two variables. So this will be calling for this one. So 30 will be pointing towards the data, and next will be none. So automatically 30 and none. So let it be 1300 is the address of this node N3. Now what we have to do? N3 address should be copied at N2.next. So this is data and this is next. So N2.next is equal to N3. So automatically none will be replaced with the address of this one. So automatically link will be established. So like this we can create the nodes. That means creating the linked list. Right? So now, so this is the creation of a linked list, and now we have to display. How to display? So in order to display, we'll write one more function called a def display function of self, the first parameter self. Now what we have to do? We have to travel from first node to last node. So for that purpose, and we should not change the head, right? So we will give one temporary variable and we'll assign this head to that temporary variable, and we can travel this temporary variable throughout the all nodes, right? So temp is equal to self dot head. Temp is equal to, I will write here, def display of self. Right? Now I will write some temp is equal to self dot head. Now how to travel? So if it is an empty list, we know that if self dot head is none, because if there is no another node, or if it is having no nodes, so we have created with a none. So if self dot head is none, simply print empty. So we'll print empty. Otherwise we need to travel from the first node to last node, right? From the first node to last node. So for that purpose we are just assigning the head value to temporary. So while temp, that means it will be moving from one first value to last value. So while temp, that means until it reaches to the last element, so we need to move temp is equal to temp dot next. So first, while temp means here the head, right? Here the temp value is 10. Temp is 10, so it is a true. Now temp is equal to temp dot next. Now temp will be temp dot next means 1200. So automatically it will be moving towards this one. Okay, again it will check for temp 20. Again temp is equal to temp dot next. So again it will move here. Again 30. Temp is equal to temp dot next. It will move here. So there is no other node, right? It doesn't move there. So automatically temp dot next is none. So if temp is none, automatically the loop will be terminated. So for that, each and every iteration we are going to print temp dot data. So before moving to the next iteration, we'll print the data, and then we'll go with the temp is equal to temp dot next. Automatically after printing 10, the temp value will be changed to next node. Okay, so like that we'll use the display function, right? So don't worry, I will execute the program. So still if you are having any doubts, you can the doubts can be clarified here. Okay, don't worry about that. So temp dot data, temp is equal to temp dot next. So this way we can create the list and we can display all the nodes of a single linked list, right? Hope you understood this one, how to create a node. So here we are not having the pointers concept, so we are creating a class node and we are giving some two variables for this one. So for every object of this node we are having some two variables, right? So if you create a node, two variables will be there. One is the data, another one is the next. That means address of the next one, right? So let's stop here. So let us execute the program, so that if you are still having any queries, so definitely all the queries will be clarified after watching the execution. So let's move on to the system. Hello friends. So just now we have seen the single linked list. That means how to create a node and how to insert the elements, right? So how to display the elements of a single linked list. Now I will execute the thing. So first of all, we'll create a node with two elements, that is a data and next, right? So every node will be having two elements. One is for data, another one is for storing the address of the next node. So for that we'll go with the class node. This is for node creation, right? So here we'll go with the constructor. So def underscore underscore init underscore underscore self, and also we'll go with the data. Okay, so we don't go with the next because for the first thing the next will be none, right? So here just initialize self data is equal to data and self dot next is equal to none, so no value. So because for the first node, if you are creating this linked list with one node, the data will be actual data, and the next one, that means self dot next, will be none. That means there is a no connection for the next node because it is having only one node. So next we'll create a one more class. So this is for node creation, right? So next one we'll create a class for single linked list, right? So here we'll define the head. Okay, so the same thing. So we'll go with the constructor in order to initialize the variables. So self, and go with the self dot head is equal to none. Initially we'll take none because after creating the node, the head will be pointing to the first node, right? So for this, now we have created a node with the two elements, that is a data and a next, and single linked list. So initially that's an empty list. Now we'll write a one more definition for display. So in order to display the elements of a linked list, the nodes of a linked list, we'll go with the display. So self if self dot head is none. Self dot head is none. That means if the head is none, that implies linked list is empty. So linked list is empty, right? Now we'll create a object for a single linked list. Okay, so I will go with the L is equal to single linked list. So just I have created the object. Now before creating the node, so similar to this L, we have to create an object for node with the two data. Okay, with the data and the next one. Now before creating, we'll call this display function. So it should display empty linked list. If you execute this one, we'll get linked list is empty because we have created the node. That means we have just declared the node, and also we have initialized the head as none. So we are not creating any node. Now we'll create the node. So n is equal to node of 10. So first element I am giving as 10. Then see what about the, so here you can observe n dot data will be 10, right? N dot data will be 10. What about n dot next? N dot next. So we are not having n dot next, right? So because it is having only a new node, this was no new node. Now consider this as a head because this is the first element. Now we have to initialize the head to this one. Head is equal to so linked list, empty linked list, L dot head is equal to n. Okay, L dot head is equal to n. Now you can observe L dot head is equal to n means the data part is 10 and the next part. So here the next means the address of next node. Okay, this is the address of next node. Address of next node. Okay, so this is the first node. Okay, this is the first node. So automatically the address of next node will be null. Then we'll create a one more node. N1 is equal to, or simply you can display, we'll get only one element. See, so let us create one more element. So N1 is equal to node of 20. Now, what about the address of N1? That should be at N dot next. That means L dot head dot next. So you can observe here L dot head dot next will be N1. Okay, so the first node is 10. The first node is 10 and the second node is 20. So the address of 20 should be at this N dot next. So here N is initialized to L dot head. So that's why I have given L dot head dot next is equal to N1. So this is the next node. The address of next node will be linked to the first one. So just see. Now we need to display the elements. If it is a linked list if the linked list is empty, we are getting the linked list as empty. Now we are supposed to display the elements. So how to display the elements? For that we need to write. So else if the linked list is not empty, just go with the temporary, take the some temporary variable which is assigned with a head, right? Now while temp, so unless it goes to the end value, it will be iterated. So print temp dot data, and just for representation I am giving some arrow mark, and for every second element it should be printed in the same line, so I am using some AND operator. Right? And immediately after displaying the data, just forward the temp is equal to temp dot next. Automatically it will move to the next one, right? Now if you execute this one, we'll get 10 20. The first node is a 10 and the second node is a 20. Okay, and if you go with the next one, see N2 is equal to node of 30. Now the address of N2 should be at N1 dot next. So N1 dot next is equal to N2. Okay, and just execute, we'll get a 30. Right? So hope you understood this one. So if it is an empty list, so just create a node with the two elements, two variables, that is the data and next. So initially take the next as none because for the first node it will be none. And create one more class with a linked list. So for all the elements, I mean inserting the elements that will be linked to this single linked list. So here also I am taking one parameter, that is a head as none. So default there are no elements or there are no nodes, so head will be pointing to nothing. So that's why I have given head as none. So while displaying that, I am writing a one more function called display. So while displaying, so if self.head is none, automatically we can say that linked list is empty. So I am displaying this one. Else if it is not empty, okay, then take one temporary variable and assign the self.head to temporary, because we have to traverse this temp from first element to the last element. Okay, so we should not change the head value. We should not change the head value. So that's why we are just keeping this head value as same, and we are assigning that head value to the temporary variable, and we are just iterating the temporary variable from the starting position to the last position. So, and displaying each and every data, and after displaying the data, just we are changing the temporary value. Temp is equal to temp dot next. So automatically it will move with the next element, because temp dot next will be having the address of next node, right? So node of 10, so 10 will be taken here. So automatically the self dot data will be data, that means a 10, and self dot next will be none. And then immediately after creating the second one, we have to give the second node address to the first one, right? So that's why we have given some L dot head dot next is equal to n1, or simply you can go with a n dot next. Okay, n dot next is equal to next. That's also that's also common thing, right? So same, it will work same, n dot next or L dot head dot next, right? So after creating the n2, we are creating the address of n2 in n1. So that's why n1 dot next is equal to n2. Immediately n2 value address will be stored in next. So display function, we have to call this with the help of this object, this class object. So we have created the L as a class object. So I am displaying this one, so that we are getting this one. And if you increase the node, n3 is equal to node of some 40, then immediately the n3 address should be at n2 dot next. n2 dot next is equal to n3. So if you execute this one again, we'll get a 40, right? So hope you understood this one, how to create the node and a single linked list, how to create the single linked list, and how to display the nodes of single linked list. Okay, so then our next session will be having the insertion. So we can insert the elements at the beginning, at the end, or at the specific position. So we'll see all these three, how can we insert the elements into a linked list based upon the position, so in the next session, right? So hope you understood this one. If you are having any doubts regarding this introductory part, so feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.